Assalamualaikum, good afternoon. So we continue our lecture today. Last topics, okay. Maintenance of pneumatic and hydraulic system. In this topics, you are introduced to principle of maintenance and also give you several problems that can be occurs in pneumatic and hydraulic system. Right. Okay, so first we begin with the maintenance. Maintenance is basically works that subjected to avoid or to mitigate the consequences of equipment failures. Okay, in general, there are three types of maintenance. First is preventive maintenance. Second is predictive maintenance. Third is the corrective maintenance. In preventive maintenance, there are activities that include partial or complete overhauls that's at specified periods, okay, such as oil change, lubrications, modification, minor adjustment, and so on. So any works performed on the machinery which is already scheduled, okay, and then that's why the preventive maintenance is regularly performed on a piece of equipment to lessen the likelihood of failure. Okay, and the ideal preventive maintenance program is typically will prevent all equipment failure before it occurs. Okay, because we already plan it before it happens, we already predict it. Okay, and also the other one is the predictive maintenance. Predictive maintenance designed to help to determine the condition of in-service equipment in order to predict when maintenance should be performed, okay, which is related to the preventive maintenance. This approach will promises a cost saving over routine or time-based preventive maintenance, okay, because tasks are performed only when a warranted period will comes, okay. And then the third one is corrective maintenance. This just happens when the typically have performed when the machine already failed. Okay, this maintenance type is performed to identify, isolate, and rectify a fault so that the failed equipment or machine or any system can be restored to any operational condition within the tolerance or limits established for in-service operations. Okay, in terms of industry, basically we try to avoid this kind of maintenance because this corrective maintenance perform after the machinery or equipment is failed. Okay, so this there are three types of maintenance types exist today. Okay, now if maintenance, if machinery already fail or have problems, okay, the first steps we have to find is what is the problem, okay, usually known as fault finding, where it is in hydraulic system. Several steps such as visual and manual checks should be made for any obvious irregularities. This can be done uh, by check the noise, by check the vibration, by check the heat, leaks, or any unusual motor current happens in our pumps on and other components in the hydraulic system. Okay, now today with the advance of technology, this can be monitored. The hydraulic performance can be monitored by several measurement techniques using flow meter, pressure gauge, and thermometer. Okay, because of hydraulic system is depends on the flow and pressure of the pump to provide necessary power for actuator to produce useful work. Right. That's why this equipments or this gauge can be used to see what is wrong with our pumps. Okay, and to this it is sold in one kit known as a flow pressure test kit. Okay, typically it's already there. It's already flow meter, pressure gauge, also thermometer. So we can check all parameter necessary to in maintenance of hydraulic system. Now, basic technique for hydraulic system fault finding. Okay, first, knowing the delivery rate of the pumps. Okay, it is a vital steps because when we know the flow rate of the pumps, so if there is problems with our valve, for example, so we can see it directly from the flow rate. Okay, whether there is leaking or there is something else over there. Okay, and usually the hydraulic pump are typically positive displacement pump. Okay, if a pump is delivering fluid, it must be going somewhere. Okay, so we can trace. Okay, so you can trace the pipeline or the hose line or the tubing line from the hydraulic system. Okay, and then it is also have to remember sometimes the flow rate flow meter read the reading is by showing us the velocity of the flow, and then also the actuator also determined by speed. Okay, so from these two we can relate each other what happens to our hydraulic system. And also acceleration of actuator usually determined by pressure. That's why by reading the pressure gauge reading, so we can see what happens to the actuator. And also the ability of cylinder to withstand force related to pressure. Okay, and then it is known that the pressure at any point is determined by the lowest pressure the system can be provided under current conditions, which is we can see if we can compare it with the pressure relief valve setting. If the pressure is inadequate with the pressure relief valve setting, so meaning the system is okay, but it is far than pressure relief setting, so meaning something wrong with the hydraulic system. Okay, common cause on the hydraulic system breakdown typically clogged or dirty oil filters. Okay, second is inadequate supply of oil in the reservoir. Can be because of leaking of seals. Can be because of loose inlet lines that cause a pump to entrance air. Okay, sometimes it's because of incorrect depth of oil, meaning the viscosity of oil is not suitable for the system. And then can be excessive oil temperature. Can be because of excessive oil pressure. Okay, so that's why three kind of gauge typically used in finding problems in hydraulic system: pressure gauge, flow meter, and thermometer. Right. Now, if the problem is because of noisy pump, okay, you got problem on noisy pump, there are several possibilities that makes the pump noisy. It can be because of loose or damaged inlet line. It can be because of cavitation or air enter the pump inlet. Okay, it also can be because of misalignment of pump and the motor driver. Okay, which is the installation of the pump itself. Also, it can be because of dirty inlet strainer and filter. Also, it can be shattering pressure relief valve. Okay, something wrong with the pressure relief valve. And also can be because of excessive speed of the actuator. On the worst thing is because of the pump already fault. Okay, in total faulty, meaning you have to dismantle the pumps. Okay, now second problems, okay, in hydraulic pumps is due to low pressure. Okay, the low pressure can be because of leak in hydraulic line. It can be because of air trap in the fluids to make cavitation. Okay, and then this also maybe because of too low PRV setting. All right, and another one is because of the PRV have problem itself, such as not correctly seated on the valve sheet. Okay, And the worst thing is because of the pump already fault, and also the actuator already fault or worn out. Okay, so these are the typical problem if we find low pressure in hydraulic system. Okay, another problem is no pressure at all in hydraulic pressure system. Okay, first, because of wrong direction of pump, instead of pumping it's become vacuuming. Okay, so we have to check the installation of the line. Okay, another problem, because for no pressure, is rupture of hydraulic line, meaning there is hose already rupture or the tube already rupture somewhere, so you have to check the hydraulic line. And then the PRV broken, that makes pressure relief valve stuck open, still open, cannot return back to original position. And then another one, because of a broken pump valve, or else the oil level is very low in the reservoir, so there is no oil circulated inside the hydraulic line. And the last, because of faulty or worn out actuator. Okay, then another problem is if the actuator fail to move. Okay, if the actuator fail to move, there are several possibilities. First, the pump is already fault. Okay, and then the possibility the directional control valve fail to shift it, or else the system pressure very low, so it cannot move the cylinder at all. Next problem is the pressure relief valve stuck open. Okay, so a lot of pressure loss. And then the faulty actuator, so maybe because of leaking or worn out. Okay, and then the external load is too high. Okay, for the actuator. Okay, of course, if it is related to the size of the actuator you design. Okay, another problem in actuator, it is can move but slow or erratic motion. Okay, several possible problems for this kind of problems. Several cause for this problem is first, if there is air trap in the system, so the pressure lose in the system. Okay, and then the oil is not suitable, for example, it's too viscous. Okay, too viscous for small actuator, it will slow or erratic motion, will give us slow or erratic motion. Okay, another cause is because of the worn or damaged pumps. Okay, of course it will not provide good pressure. Another one is speed of pump is very low. Okay, which is not suitable for the actuator, or it is not suitable for the load itself. Okay, another cause is the excessive leakage in the actuator or in the valve, so a lot of oil will go out, pressure lose. Okay, another problem is because of faulty flow control valve, so it makes the movement of the actuator slow or erratic, or it is faulty of a pressure relief valve. Okay, low pressure. Okay, if PRV fault, meaning low pressure, cannot control pressure anymore. Okay, and the next cause is because of low oil level in the reservoir. And next cause is the blocked air breather in the reservoir. Okay, so meaning it is related to design of the oil tank. Right. Now, next problems can be found in hydraulic systems is overheated hydraulic fluid. Okay, this can be because of a not active or faulty heat exchanger. Okay, if there is heat exchanger, especially if you use the hydraulic system in a cold climate. Okay, or another big cause is because undersize of component or piping. Okay, as this hydraulic fluid is not suitable, maybe too viscous or maybe too thin. Another cause because of the dirty fluids. Okay, meaning filter already fault, or else to small reservoir. Okay, so there is no temperature exchange between uh, distribute oil and the oil in the tank, or else it is because of low level of oil in the reservoir. Okay, and then because of excessive pump speed, because so friction increase, temperature increase, then hydraulic fluid also heat up by this kind of reaction. Right. Next cause is because of a clog or inadequate size of air breather. Okay, and then the last one is because of overload system. Okay, so overload system related to the friction. If friction high, so the temperature also high, then hydraulic fluid temperature also high. All right. Now, another things we have to consider in maintenance is the safety factor. Okay, factor of safety. Okay, because of hydraulic and pneumatic system are no less dangerous, but tend to approach in far more free manner. Okay, so we have to be careful. Okay, high pressure air or high pressure oil release. Okay, that release suddenly can reach an explosive velocity and can easily harm, blind, or kill operator around the hydraulic or pneumatic system. Okay, and also unexpected and movement of the components such as cylinder can trap or can crush limbs of the operator. Okay, that's why in hydraulic and pneumatic system we must ensure to install protective equipment, okay, such as by design the circuit properly, right? And then in the factor safety, spill hydraulic oil can be very slippery, which is if you're not careful, if someone cannot not seeing it, it will force operator or someone around the hydraulic system can be forced, thus make them injury. Okay, and then because of this factor, the OSHA or Occupational Safety and Health Administration describe and enforce safety standard for industry. Okay, where hydraulic and pneumatic equipment is operated. Several criteria regulated by OSHA is include workplace, okay, including the safety of floors, entrance and exit areas, sanitation, and also fire protection. Okay, and then OSHA also regulate about machine and equipment, okay, including noise level, machine guards, inspection and maintenance method, safety device, mounting, anchoring, and grounding of fluid power equipments. Okay, next things regulated by OSHA is the materials. Okay, this including the effect of hydraulic oil toxic fumes, explosive of dust particle, okay, explosive dust particle and atmospheric contamination because of the use of hydraulic and pneumatic components. Okay, in terms of employee, OSHA regulate some regulation about personal training. Okay, regulation about PPE and medical and first aid service, which is even in our university, this is also implemented. You can see around the class there will be medical and first aid service. Okay, must be located, right? And OSHA also regulates power source. Okay, it is because of fluid power can be controlled by electronic devices such as in electrohydraulic and electropneumatic system. So it is also must be properly isolated. Okay, must be properly isolated, must be properly labeled. Okay, so it is the regulation of OSHA. And then process standard. Okay, it is OSHA also regulate process standard for industrial process. okay, such as welding, spraying, blasting, and machining, which is also related to the use of hydraulic and pneumatic system. Okay, and the last in level of administrative, okay, administrative regulation, OSHA also regulate that in area where there is machinery, there should be a poster recording accident, illness, and other exposure type occurrence must be attached on several places. Okay, these are several regulation by OSHA, which is I'm not sure you will have. I think you will have the OSHA and ethics in year 4. You will learn about this further later. Okay, now in terms of in hydraulic system cleanliness, there will be a criteria by ISO. Okay, inadequate control contamination will typically bring to premature failure and unreliable operation. That's why the particle level in hydraulic oil must be maintained, which is already regulated by ISO number 4406 standard. Okay, for example, ISO already have chart, okay, already chart in this kind of regulation with this by code ISO code 1 to ISO code 28. Okay, this code basically show us how many particle with specific range of size, okay, in microns, okay, in content in hydraulic oil. For example, ISO code 6, okay, for the particle with size 14 micron, if give us code of 6, meaning the particle inside the oil is 0.232 until 0.64 ppm, okay, or in millimeter of a fluid, right? So this is regulation on system cleanliness. Alright, in hydraulic system, there is also we have to consider is environment issue. Okay, environmental reservation rules and regulation has been established, okay, concerning operation of fluid power system. Okay, the fluid power industry is responsible and to meet such regulation, such as development or use of biodegradable hydraulic fluids, maintaining and disposing hydraulic fluids, reducing oil leakage, and reducing noise level. Okay, these are several criteria for fluid power system. Okay, in maintaining and disposing of fluids, okay, several recommendations should be reconsidered. First, select the optimum fluid such application involved, including fluid desired properties, which is will fulfill system operating pressure and temperature. Second is use well-designed filtration system to reduce contamination and increase useful lifetime of the fluids. And then follow proper storage procedures for unused fluid supply. Then transport the fluids from container to hydraulic system must be done carefully to avoid contamination. And then regularly check oil physical properties such as viscosity, acidity, specific gravity, and color. Okay, which is related to preventive and predictive maintenance. Maintain all hydraulic components according to manufacturing specification. Then perform corrective action to prevent leakage, if any. And then properly dispose used hydraulic fluids. Okay, so these are several maintenance can be performed for hydraulic and system. Now for the pneumatic system, okay, now just give you basically the steps same. You have to find the fault first. Now just give you example general problem in reciprocating compressor such as piston compressor. Okay, first is loss of capacity, which is can be extreme reduction in capacity or no delivery at all. Okay, it can be because of a plug filter, can be because of a block intake line, can be because of jam unloader which hold the suction valve, or can be because of gasket failure. Right? And then if in not delivery of reciprocating compressor, okay, usually because of air demand exceeds rating of compressor, then because of section valve jam or broken, okay, it can be because of valve seat gasket failure, or else can be because of leaks in piping, okay, because of piston ring once or broken. It is because of system pressure set too high in PRV, or speed too low, because of, and also bad sleeping and etc. So that's typical problem if piston compressor lost the capacity. Okay. Second, another problem in piston compressor is noise and vibration. Okay. If vibration, high vibration happens, okay, it typically can be because of inadequate foundation, which is you install it in improper installation. Okay, sometimes because of compressor is not properly grouted, meaning the floor where you install the compressor is not strong enough, or else because of unloaders not function correctly, okay, related to the system, and then because of excessive pipe strain or incorrect piping design. Okay, that's a typical cause for high vibration. Now another problem in compressor is high noise. Okay, it is can be caused by loose piston. Okay, loose piston can bring to a lot of problems. Okay, such as because of insufficient head clearance, or else it can be because of too great piston to cylinder bore clearance. Okay, and then can be cause of broken piston ring. It also can be caused by loose rider bands, or can be cause of loose or broken valves. Okay, these are several problem for noise. Okay, and then another cause for high noise in compressor is also can be because of moisture carryover or liquid slugging. Okay, it can be cause of a motor or compressor bearing too high. Can be also cause of a lack of lubricant oil. Okay, it can be cause of belt sleeping. Also can become because of leaking gasket or joint, loose flywheel, loose bearings, crosshead pin to bushing clearance too high. Okay, mechanical packing loose in the glands. Okay, excessive crosshead to guide clearance, and connecting rod hitting end of piston rod in crosshead. Okay, maybe some of you is not familiar with this components of a compressor, but because of who you are, mechanical technologies, I hope you can read about what is inside a compressor later, right? And then the last problem in compressor, if the compressor totally failure to run. First problem is because of valve failure, maybe broken already, or else maybe because of the electric motor already overheat. Okay, or else it can be because the fuse we employ to in motor is too small, or else it is a source of voltage. Okay, source of voltage is low, or it can be pressure switch differential is set to close. Okay, and then the compressor does not unload for starting, so meaning something loose inside the compressor, and then the motor bearing are beginning to seize. Okay, these are typical problems if the piston pump fail to run at all, right? And how we can monitor it? Okay, some diagnostic tool we can use to monitor noise. For example, noise is easy. Of course, we can use a sound meter, but also we can use our sense, such as our ear. You can see, you have to practice your noise when a compressor run in normal condition. Okay, and you will able to differentiate it when the sound is in normal condition or the sound is in abnormal condition. Okay. Now, if you want to check the pressure, we can use two pressure gauge method. We install two pressure gauge at two different locations, so we can observe whether there is a pressure leaking or there is a increased number of pressure. And then for flow rates, we also can use not temperature indicator, it is flow indicator. Okay, you can use flow meter, and temperature you can use two temperature indicator. You can install thermometer at two different locations, so we can obtain temperature reading from the equipments. Right? Okay, that's all for